Graphing inequalities. The graph of an inequality represents all of the infinite solutions to that inequality, where a solution to an inequality is a number that if you plug it in for the variable makes the inequality statement true. Let's look at this first example, x is greater than or equal to -4. So that statement, x is greater than or equal to -4, represents any number that is greater than or equal to -4. For example, -4 is one possible solution. -4 equals -4, so -4 is certainly greater than or equal to -4. I can indicate that that's a solution by putting a dot on my number line. What's another number that's greater than or equal to -4? How about -3? Yep, that's true. -3 is greater than or equal to -4. What about 2? Yep, 2 is also greater than or equal to -4. What about 5,000? Yep, that's also in the solution set. 5 is greater than or equal to -4. So when we're graphing the solution, or when we're graphing this inequality, x is greater than or equal to -4, we're going to put a closed dot at this boundary point because -4 is part of the solution. That's my straight line. And then we're going to draw an arrow to the right, indicating that every single point on the right, on this number line to the right of -4 is a solution to that inequality. Next example, x is less than or equal to 4. What are some examples of solutions here? Again, 4 is a solution. 3 is a solution. 3 is less than or equal to 4. -2 is a solution. These are just example solutions. Yours don't have to be exactly the same. And then don't think that only integers are possible. So 1.5, 2/10, -3,000. Those are all numbers that are less than or equal to 4. So again, the way that I will graph this inequality to represent that every point to the left of 4 is a solution is I'll draw a closed dot here. That tells me 4 is a solution, and then an arrow to the left. Here's my first time where I don't have that equals to sign. So x is greater than 2. This represents any number greater than 2, so 2 is not part of the solution. However, 2.5 is, 2.5 is, 3 is, 7 is, any number greater than 2, but 2 is not a part of the solution. What I do here then is draw my boundary point, that 2, as an open circle. That open circle shows that the 2 is not included in my solution, but every number to the right of 2 is, every number greater than 2. Similarly here, no equal sign, x is less than 0. 0 is not part of my inequality. It is not a solution to my inequality. However, -1 is, -10 is, -1/2. Any number less than 0, but 0 is not a solution to my inequality. So I use an open dot there, not filling it in, and draw an arrow to the left. In summary, greater than is going to have an arrow to the right, as is greater than or equal to, but only the equal to has a filled in dot. If we have just a greater than symbol, our boundary number is not a member of the solution set, so I have an open dot there. Similarly, less than and less than or equal to have arrows to the left, indicating that all the values smaller than that number are solutions, but less than does not include the boundary number, does not have that equals to. So less than is an open dot, whereas less than or equal to has a filled in closed circle. If we want to practice going the other way, rather than graphing from the algebraic inequality statement, we can be given the graph and figure out what that inequality statement says. Those numbers are really small, but I think that's a -2. So this inequality statement for this graph would be x is greater than or equal to, look at my arrow to the right, closed dot, and then that boundary point, -2. -2 is a solution as well as every number bigger than -2. This is a very important hint, which is that we need to move any variable on the right side to the left, and actually I will require that. Students think they don't need to do this, but most of the time, I would say almost all of the time, if students don't do this, they will graph this incorrectly. So we want to go ahead and rewrite it with the variable on the left. This says 2 is greater than x. That's the same as saying x is less than 2, making sure that the inequality is still making the same statement. So here the alligator eats the 2, it's still eating the 2. So x is less than 2 allows me to graph this without making any mistakes, with an open circle at 2 and then an arrow to the left. Please notice that only if the variable is on the left, we can match our inequality with the arrow. So greater than, that matches the arrow. Less than matches the arrow. Greater than, matches the arrow. Less than, matches the arrow. Greater than, less than. But this only works if the variable's on the left. So I need you to rewrite all of your inequality statements with the variable on the left.